In this lecture, we will be studying about a regular grammar. So before we start with regular grammar, let us try to understand what is a grammar. So in normal human languages, what is the use of grammar, or why do we use grammar? So grammar is actually a set of rules that we used for proper conversation with each other. So in the same way, for writing computer languages also, there is a mathematical model of grammar which is used to write the languages in the correct way. So Noam Chomsky, he gave a mathematical model of grammar which is effective for writing computer languages. So this person Noam Chomsky, he gave a mathematical model of grammar which can be used for writing computer languages. And according to Noam Chomsky, there are 4 types of grammars which we will discuss here. So the types of grammar that we have according to Noam Chomsky are type 0 grammar, type 1 grammar, type 2 and type 3 grammars. So we will discuss them starting from the bottom. So first let's see type 3 grammar. So in type 3 grammar, the grammar that is accepted are regular grammar, which we will be studying in this lecture, and then the language accepted by this type 3 grammar are regular languages, which we have already studied in the previous lectures, and then the automaton that is used for designing this kind of grammar, that is type 3 grammar, is finite state automaton. That is the finite state machines or finite state automata, which we have already studied in the previous lectures. Okay, and then we have type 2 grammar, in which the grammar accepted are context-free grammar, and then the language accepted by type 2 grammar are context-free languages, which we will be studying in the following lectures, and then the automaton that is used for designing this is the push-down automata. Alright, and then we have type 1 grammar, in which the grammar accepted is context-sensitive grammar, and then the language accepted by this is context-sensitive language, and then the automaton that is used for designing this is the linear bounded automaton. And then we have type 0 grammar, in which the grammar accepted are unrestricted grammar, and then the language accepted by this is the recursively enumerable language, and then the automaton that is used for designing this is the Turing machine. Okay. So these are the types of grammar that we have according to Noam Chomsky's classification, and we will be starting with a regular grammar which will be discussed in this lecture. So first let us see how can we define grammar, and then we will come to regular grammar. Okay, so here we will see how can we formally describe grammar. So a grammar G can be formally described using 4 tuples given as G equal to V, T, S and P. So a grammar G can be defined using 4 tuples which are V, T, S and P, and let's see what does these tuples mean, where V equal to the set of variables or non-terminal symbols. So V are a set of variables or non-terminal symbols, and T is a set of terminal symbols, and S is a start symbol, and P is a production rule for terminals and non-terminals. Okay, so V, T and S are easy to understand, but let us try to understand what is P. P is a production rule. A production rule has the form alpha tends to beta or alpha gives beta, where alpha and beta are strings on V union T. That means it can belong to the set of non-terminal symbols and terminal symbols, and at least one symbol of alpha belongs to V, which is the set of non-terminal symbols. So don't worry, even if it is a bit confusing, it will become clear when we take the example. So here we have an example given. We have a grammar G, and then it is equal to, and we have a set of symbols here S, A, B, then we again have small a, b, S, and then this production rule. So let us try to understand this example grammar which is given here, and let us try to see what are the tuples in this. So we have the first tuple, which is V, which is the set of variables or non-terminal symbols. So here it is S, A and B. S, A, B. These are the variables or the set of non-terminal symbols. And then we have T, which is the set of terminal symbols, which are A and B. A and B are the terminal symbols. And then we have start symbol S, which is equal to S itself. Here start symbol is given by S, and then we have a production rule P, which is given by this. So the production rule is given like this: S gives AB and A gives small a and B gives small b. So this is the production rule of this grammar. Now let us try to take an example and see some strings that can be formed using this grammar that is given here. So we have to look at the production rules over here. So our starting symbol is S. So I take S and I can say that S gives AB. From this production rule, S gives AB. So S gives AB, and then we also have in the production rule that A gives small a. So instead of this big letter A, I can write small a because A gives small a. And then this B, let me write it as it is. And then this B also, we see that it gives small b. So this A I write as it is, and instead of this B I can write small b by this production rule. So we get a string AB. Now this string AB is something that is designed using this grammar. So this is how we will design strings, or we will find out strings that will be accepted by certain grammars. Okay, so I hope that made the concept of grammar clear to us. So if that is clear, let us go to the next part, that is regular grammar, which we will be discussing now. Okay, now let's come to regular grammar. So regular grammar, it is of two types. It can be divided into two types. The first one is a right linear grammar and the other one is a left linear grammar. So let us see what is the meaning of right linear grammar and left linear grammar, and let us try to find out the difference between them. So a grammar is said to be a right linear if all productions are of the form A gives xb and A also gives x, where A and B belongs to V, which is the set of non-terminal symbols, and x belongs to T, which is the set of terminal symbols. So if you have a grammar and if the production rules are of this form, here if you look here, we see that x is a terminal symbol and B is a non-terminal symbol. Now if the non-terminal symbol lies to the right of the terminal symbol, then it is said to be a right linear grammar. So here we see that x is a terminal symbol and B, which is a non-terminal symbol, lies to the right side of x, the terminal symbol. So it is a right linear grammar. And then left linear grammar is just the opposite of that. I hope you can already see the difference. A grammar is said to be left linear if all productions are of the form A gives Bx and A gives x, where AB belongs to set of non-terminals and x belongs to set of terminal symbols. So here we see that x is a terminal symbol and B, which is a non-terminal symbol, lies to the left of the terminal symbol, which is x. So this kind of grammars which have this kind of production rules are said to be left linear grammar. So let us take a simple example to understand it in a better way. So here let me take an example where I have a grammar whose production rule is of the form S gives A, B, S and also B, let's say. So S gives A, B, S and also B. So here A and B are the terminal symbols and S is the non-terminal symbol. So here we see that S, which is a non-terminal symbol, lies to the right of A and B, which is the terminal symbol. So this is a right linear grammar. So this is right linear. Now if I have another grammar S, which has a production rule of the form S gives S, B, B and also B. So here B is the terminal symbol and S is a non-terminal symbol, and we see that the non-terminal symbol S lies to the left of the terminal symbols B. So this is a left linear grammar. So this is how you identify right linear grammars and left linear grammars, and this is the difference between them. So I hope this made us the concept of right linear grammar and left linear grammar clear to us, which are the types of regular grammar, and we also understood what is the meaning of grammar, and we also saw the types of grammar according to Noam Chomsky's classification. So I hope this was helpful to you. Thank you for watching and see you in the next one.